So now we're going to talk about how to solve equations of the same form. And again, those were equations, but those are really identities. In equations, what we do is we use our basic algebra techniques that we already know, just like solving any equation. We're going to solve it like this. And what I mean by that is this. Here's an example. Let's take the equation 2 sine minus 1 equals 0. Well, we can rewrite this as something that looks something like more familiar we know, which is 2y minus 1 is equal to 0, where y is the sine function itself. How would you solve this? Well, we would just add 1, and we would get 2y is equal to 1. We're going to divide everything by 2, and we get y equals 1/2. So again, what I'm looking for is where are my y values 1/2 at? Well, they are 1/2 here at pi over 6. They're also 1/2 here at 5 pi over 6. So my solutions are going to be, for this particular case, we write our solutions in terms of the x coordinate, or in terms of this particular case, our variable is theta. So theta is equal to pi over 6 plus or minus 2 pi n, the general solution, and theta is equal to 5 pi over 6 plus or minus 2 pi n. And again, we're writing the solutions based on what matches from the circle. And we're going to put that 2 pi over in to make it a general solution. Let's do another example. So here we have, solve the equation tan squared theta minus 3. I'm not going to change the x and y's because I'm just going to solve this equation. And what you're doing is you're isolating the particular function this time, tan squared. So when I do that, I'm going to add 3 to both sides. From there, I get the tangent squared of theta is equal to 3. And now I want to get a single tangent here. So to do that, we just take the square root of both sides. Now, here's the issue with square roots. Remember, when you take square roots, you get 2 solutions. So for this, I get tan theta is equal to plus or minus the square root of 3. So I need to find all the tangents that have a square root of 3. And remember, to get that, then, the tangent function itself, tan theta is equal to the y value over the x value. So in order to get that root 3, it has to be, you have to have a y of square root of 3 over 2 over 1/2. Because these are going to cancel and you're left with just square root of 3. So that's going to be everybody's whose coordinates then are x has to be 1/2, y has to be root 3 over 2. And because it's a positive or negative, it's going to be every one of those values that give me that. So everyone that has a coordinate like this, regardless of signs, will give me that. So that'll be pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. We're going to write them all as general solutions. So it'll be theta is equal to, well, you get the hint of the general solution. I'm not going to write them all. I'll write one of them as it. So I'll write pi over 3 plus, and tangents are different in terms of their repeating, because they're not repeating over 2 pi. Tangent actually repeats over pi. So you'll write the tangent as pi over n. Tangent repeats itself over pi. That's why the period is pi for a tangent, and cotangents. The other functions are all 2 pi, but tangent is different. So it'll be that. And then you can also put theta is equal to, the other values are 2 pi over 3, 4 pi over 3, and 5 pi over 3. And they'll all be plus or minus this pi n. And again, they're pi because they are tangent. So square root of 2 cosine theta minus 1. Here, we're going to isolate that cosine theta. So to do that, we're going to add 1 to both sides. And so I get square root of 2 cosine theta is equal to 1. And I'm going to divide everything by the square root of 2. And when I do that, I get cosine theta equals 1 over the root 2. Problem with that is we can have square roots in the bottom. So we'll rationalize and get the root of 2 out. When we do that, we get square root of 2 over 2. Remember, cosine is the x-coordinate. So who has an x-coordinate of root 2 over 2? Come back to your circle. Pi over 4 has an x-coordinate of root 2 over 2. 7 pi over 4 also has a coordinate of root 2 over 2. And so when we do this, we get, in this terms, theta is equal to pi over 4 plus or minus 2 pi n, because we're dealing with cosine again. And theta is equal to 7 pi over 4 plus or minus 2 pi n.